Now coming to the what you can say the atomic structure. So in the Thomson's experiment, Thomson actually did the experiment for the discovery of electrons. You know that he did the experiment on the cathode rays. From there he told us the properties of the cathode rays, from where we come to know that the charge of the electron is negative. You can say that. Now, who gave the name electron, or who coined the term electron? The term electron was coined by Stoney. You might be thinking, why the name electron was not given by Thomson? No, Thomson called this as negatrons. Negatrons, negatrons. Why? Because it consists of negative charge. For that reason he called these particles as negatrons. Later on it was named or coined as electron by Stoney. Got it. Now coming into that particular experiment only, that is the mass of the electron, which was that is the measured by the Millikan order of experiment. You know the charge of the electron, and later on the mass was measured by the formula, using the formula m is equal to E divided by E by m, isn't it? We measure the mass of the, what you can say, the electron, we can say. So that is now the mass of the electron, how much we got it? 9.11 in 10 to the power minus 31 kg. Now this mass was termed as the rest mass of the electron. Now what is rest mass? Means mass of the electron when moving with low speed. Mass of the electron when moving with low speed is known as the rest mass of the electron, which is 9.11 in 10 to the power minus 31 kg. Now the mass of the moving electron, because electrons are always moving, isn't it? So can be calculated by applying the formula, that is nothing but rest mass of the electron by, we can say, root over of 1 minus v by c whole square. The mass of the moving electron, rest mass of the electron, which is 9.1 in 10 to the power minus 31 kg, divided by root over of 1 minus v by c, where v is the velocity of the electron, which is, you know, that in 2.188 into 10 to the power 8 centimeter per second, and c is the velocity of the light, which is 3 into 10 to the power 8 meter per second. Fine. Now here you need to understand a very important thing. Two things are there. When v becomes equal to c, v and c both are equal. Got it? That is velocity of the electron is same as the velocity of light. So it gets cancelled. So it is 1 square. So 1 minus 1 square is nothing but 0. So mass of the moving electron becomes how much? It is nothing but infinity, because something divided by zeros root is nothing but infinite. Got it? So when v becomes equal to c, the mass of the moving electron becomes infinity. And when the velocity of the electron becomes greater than c, now if this value is not equal to c, v by c is not equal, b is greater than c, that means you get the answer negative, 1 minus something, which is nothing but negative. So negative root over and rest mass divided by negative root over, which is imaginary, we can say that. So hence the mass of the electron becomes imaginary. Again I repeat, in the formula, mass of the moving electron is equal to rest mass of the electron divided by root over of 1 minus v by c whole square. I have given you the notes. You can go through it. This formula is given in my notes. Just I am explaining you. Got it? So in this way, what you find is that when b is equal to c, then the mass of the moving electron becomes infinite. I said you how. And when b is greater than c, then definitely 1 minus, if a value is greater, then definitely the value will be minus 1 minus something greater value. 1 is 2, 1 minus 3. So it will be minus 2 minus 1 in this way respectively you will be getting. And if you take the root over of it and divided by rest mass divided by that root over of negative value is what? It is imaginary. So the mass of the electron becomes imaginary. Understood? In this way, the mass of the moving electron, how it is calculated. Now, in the Rutherford's experiment, after Thomson it was Rutherford's experiment, that is Rutherford's scattering experiment. After the experiment, Rutherford concluded that the radius of the nucleus is 10 to the power minus 15 meter approximately. He said that because there was no resources available, so he said it. And the radius of an atom should be 10 to the power minus 10 meter. Got it? He was correct. He was not wrong. He was correct. What he presumed. Got it? At that particular time. Now, why he presumed this particular thing? How he came to this particular conclusion? It is said that the distance of the closest approach of the alpha particle, What is the distance of the closest approach? Means how closely alpha particle approached the particular, what you can say, atom. How closely? It is of the order of 10 to the power minus 14 meter. Got it? Alpha particles, how closer it went into the went near to that particular atom. It is of the order of 10 to the power minus 14 meter alpha particle. Got it? Because alpha particle could not penetrate in from the nucleus. No? So how close it went near to that particular nucleus. That is what I am saying to you. So that is 10 to the power minus 14 meter, it went closer by. So definitely the radius of the nucleus should be less than 10 to the power minus 14 meter. It cannot be more than that. Isn't it? So if the closest approach is 10 to the power minus 14 meter, so the radius of the nucleus should be less than 10 to the power minus 14, isn't it? It has to be less than 10 to the power minus 14 meter in negative value. See, that is greater, mind it. So it will be 10 to the power minus 15 meter. It was taken to be as. So hence the conclusion was taken that the size of the nucleus is 10 to the power minus 15 meter and the size of an atom is 10 to the power minus 10 meter. Now the information of the Rutherford scattering experiment I have given in my notes. You can go through it. Alright. Now next is the radius of the nucleus, how it is being calculated. It is being calculated later on. This particular formula was taken on. The radius of the nucleus is proportional to the cube root of the number of nucleons within it. What is nucleons? Neutrons plus protons together is called as nucleons. Neutrons plus protons together is called as nucleus, which is R is equal to capital R. Capital R is the radius of the nucleus, is equal to R naught into a to the power 1 by 3. R naught is what? Is a constant, which is 1.33 in 10 to the power minus 13 centimeter, and A is the nothing but the atomic mass. We can say that mass number. R is equal to R naught into A to the power 1 by 3, where R is the radius of the nucleus, R naught is a constant, which is 1.33 in 10 to the power minus 13 centimeter, and A is the atomic mass. So the mass number, we can say that. Clear? In this way we can say. So this was being concluded by Rutherford from his experiment. We can say that. Clear? Now next we have learned this in the electromagnetic wave theory, the different types of waves. Got it? The different types of the waves, we have learnt it in the electromagnetic wave theory, starting from the smaller waves to the larger wave. The smaller waves is the gamma ray, then X-ray, then ultraviolet, then light waves. Then the light waves means the waves which you can see the human being, that is your visible light. Infrared, microwaves, then short radio waves, long radio waves. In this way we are having it. So I have given you a chart of the wavelength, the frequency, the from where it is being produced, and the detection, how it is being detected. So just you go through it, this particular chart which I have given to you, just you go through it, because this may come in short questions. We can say that it may come in your short questions. Clear? So for that reason I have given you this particular chart to you, and this is another chart I have given you, that is increasing order of this particular the wavelength, that is if the wavelength is increasing then the frequency is decreasing. How it is? Because C is equal to nu lambda. So nu is equal to C by lambda. So nu is inversely proportional to lambda. That is, nu is what? Frequency, and lambda is the wavelength. So hence I have given you this particular chart. Here it is. Again the same thing. The nu value I have given. Say gamma rays is the shortest, and the radio waves you can see it can extend up to 1 kilometer wavelength, and in between that is we are having the visible region, and correspondingly the frequency also, the chart I have given it. So just you go through it. This is for your reference. I have given to you this particular two charts. Now the most important part is the Sommerfeld's extension of the Bohr's atomic model. We can say the Bohr's theory, the Sommerfeld's extension. Here also children I have given you that is nothing but the notes I have given you. You can see in my notes it is there, everything is there in the notes. You can go through it. The Sommerfeld's model, we can say it is being there. From there you can understand the Sommerfeld's model. Got it? I have given you a complete note. Here also I am having. So what is the Sommerfeld? Now actually, according to Sommerfeld, the path of an electron around the nucleus in general is an ellipse. Got it? Bohr considered that it is circular, he said that, isn't it? But later on we according to the drawbacks of the Bohr's atomic model, we came to know no, atom is not two-dimensional, atom is three-dimensional, so it cannot be circular, it can be spherical. So Bohr said it is circular, but Sommerfeld said that the path of an electron around the nucleus in general is an ellipse, with the nucleus at one of its foci. We can say that the nucleus at one of its foci. So in order to focus, the plural of focus is foci, we can say that FOCI. In order to explain the observed fine structures of the spectral lines, what is the spectral lines? It's there, different spectral lines. We are having the Lyman, Balmer, Paschen bracket, P found in this way. Alright, Sommerfeld introduced two main modifications in the Bohr's theory. For that reason, it is written Sommerfeld's extension of Bohr theory. Alright, so according to Sommerfeld's model, for any principal quantum number n, listen carefully, this is the most important thing. I am coming to Sommerfeld's model. There are n possible orbits of varying eccentricities called suborbits or subshells. Varying eccentricities means what you find is that if you see the Sommerfeld's model, what you find is that, see, we are having two axes here. You can see this is F is there for psi. Alright, and we are having the two axes A and B. A is the major axis and B is the minor axis. Alright, and here you can see that R, that is the alpha given you, that is the angular, that is nothing but known as the azimuthal angle. The phi, which you can see, is that, which is known as the azimuthal angle, and R is nothing but that is known as the radial, that is the radius, we can say that. Radius of what? The radius of that is the ellipse, we can say that, of that angular momentum. Got it? We can say that. So in this way, the attempt of the Sommerfeld to explain the fine structure of the spectral lines failed. Got it? In this way, the attempt of the Sommerfeld to explain the fine structure of spectral lines, he failed in it. But soon, on the basis of variation of the mass of electron with velocity, Sommerfeld could find the solution for the problem of the fine structure of the spectral lines. Initially, Sommerfeld failed, but after that, later on, by using the mass of the electron, by using the velocity of the electron, he could find the solution for the problem of the fine structure of the spectral lines. Now, what Sommerfeld actually said. Alright, I said you, it's an extension of the Bohr's atomic model, which you can see, the extension of the Bohr's atomic model. Alright, so here you can see I've written everything there. The distance from the nucleus is termed as the radius vector, and the angle of the revolution is known as the azimuthal angle. I said, that's phi is the azimuthal angle, and we are having two axes. One is the major axis, another is the minor axis. As you can see is there. The tangential velocity we are having, that is when the electron is moving in its elliptical path, we are having one radial velocity and we are having one tangential velocity. Alright, so in this way I have written it here. You can just go through it. The tangential velocity of the electron at a particular instant can be resolved into two components. One along the radius vector called the radial velocity, and other perpendicular to the radius vector called transverse or angular velocity. We can say that. Clear? So in this way, these two velocities gives rise to radial information and angular and azimuthal momentum. So Sommerfeld proposed that both the momentum must be an integral multiple of h by 2 pi. We can say that. Clear? Now, here he explained us. What is that? Azimuthal quantum number, basically he explained us. So what he said us, you may write it down, this one, children. B by A, he gave us a formula, that is B by A is equal to L plus 1 by N, where A and B are the major and the minor axis. I said you just now to you, this is, here you can see A is the major axis and B is the minor axis. As you can see it on the figure on the screen, you can see A is the major and B is the minor axis of an ellipse, we can say. Alright, so B by A is equal to L plus 1 by N, where what is L? L is your azimuthal quantum number and N is your principal quantum number, so to say. Azimuthal and principal quantum number, we can say that. So in this way, what you find is that if suppose N is equal to 1, let us say, alright, then L will be equal to 0. So if N is equal to 1 and L is equal to 0, so that means it has got only one orbit or subshell. Only one orbit or subshell. So A will be equal to B, means major axis will be equal to minor axis. So if major and minor both are equal, then it will be what? It is a circle, that is spherical. So hence first subshell is your S subshell, because L is 0 now. When N is 1, L is 0, it is S subshell. A is equal to B, we got it. Alright, so it is designated as 1s, and 1s is spherical in nature. Similarly, for the second energy level, listen carefully, when N is equal to 2, there are two permissible subshells, that is L is equal to 0 and L is equal to 1. When N is equal to 2, put in the formula, B by A is equal to L plus 1 by N. So 0 plus 1 by 2, how much you get? B by A is equal to 1 by 2. That means B is equal to A by 2. Alright, so B is equal to A by 2. That means you get it. That is nothing but the second shell is, your second cell contains the subshell, which is 2s. This corresponds to L is equal to 0, is elliptical in shape and is designated as 2s. Alright, what I have taken here? L as 0. Now, when n is equal to 2, L is equal to 1. Alright, see in this figure, see here in this figure, when n is equal to 2, L is equal to 1, then what is that? We get it, B by A is equal to 1 plus 1 by 2. That is 2 by 2 is equal to 1. That means B is equal to A. So this subshell corresponds to L is equal to 1, is circular in shape and is designated as 2P. You can see it here. See here, when n is equal to 2, we get 2S and 2P. Alright, so in this way, 2S is elliptical and 2P is circular. Similarly, for n is equal to 3, L has 3 values, 0, 1 and 2. 3 permissible subshells are there, 0, 1, 2. So when n is 3, L is 0. Again put in the formula, B by A is equal to n L plus 1 by n. So 0 plus 1 by 3. Because n is 3, na? L is 0. So B by A is equal to 1 by 3. So B is equal to A by 3. Got it? Again you got it, the 3S subshell you see there. Similarly, for the P subshell, got it? 3P subshell. That is B by A is equal to L value will be 1, because n is 3 means L can have 3 values, na? 0, 1, 2. So 0 I have explained you. Now B by A is equal to L plus 1 by 3. We got it clear in this way. So that is nothing but we got 3P subshell. Similarly, we got 3D subshell. In this way, 3S, 3P, 3D, you can see it is coming on the screen. You can see n is equal to 3. So Bohr said that it is spherical. But he said that, who? Sommerfeld said that no, it is not spherical. It is being calculated in this manner. It is being calculated in this manner. The 3S, that is nothing but B by A is equal to L plus 1 by n. So B by A is equal to L is nothing but is your 1 plus 0 by 3. So B is equal to A by 3. So that is S subshell, 3S subshell, you got it. It's nothing but elliptical. In this way you got 3P, in this way 3D. So the formula is, remember that, B by A is equal to L plus 1 by n. So hence, it's a common practice to assign letters to L values. You know that. What is that common practice? So if L is 0, then electron state is S. If L is 1, it is P subshell. If L is 2, it is D subshell. If L is 3, it is F subshell. If L is 4, it is G subshell. Alright, so in this way we have given the designation corresponding to the, what you can say, the value of L0, 1, 2, 3, we can say that. That is S, P, D, F in this way. Alright, this you know it, you have studied this particular thing, you have studied it earlier, this particular thing. Alright, so this was a Sommerfeld's, what you can say, a model, we can say that. So he said that the path of an electron around the nucleus in general is an ellipse, we can say that, it's an ellipse. Alright, the path of the electron is. Alright, clear in this way. Understood? I hope so, all of you, about it. What is I said to you, that how it is an elliptical path. Everybody has understood this particular thing, that what Sommerfeld has said regarding it. Clear? So now coming to the next one more thing, let me tell you about the Sommerfeld model once more. Just let me explain you about the Sommerfeld model, we can say that. So what I said again, let me just repeat that according to Sommerfeld, the path of an electron around the nucleus in general is an ellipse with the nucleus at one of its foci. That is, you have to understand it. It is not a circular path, it is an elliptical path in which the electron is moving around the nucleus, and we are having the two axes, one major axis and one is a minor axis, which I have said you here. You can see in this particular figure, you can see it there. Got it? The velocity of the electron moving in an elliptical orbit varies at different parts of the orbit. This causes the realistic variation in the mass of the moving electron, we can say that. Clear? So I hope you understood about this. Now next is the interpretation of the hydrogen spectrum. Alright, so what was the interpretation given by Niels Bohr about the hydrogen spectrum? See, the hydrogen spectrum, you know, Niels Bohr has what you can say, he has discussed with us the how the hydrogen spectrum is being produced. The Niels Bohr has said us about it. Alright, so he already explained us that when an electron jumps from higher energy level to that of the lower energy level, then only we get this particular spectrum are being produced, isn't it? When an electron jumps from higher energy level to lower energy level, because you know that when an electron gains energy, what it does, it goes from lower to higher energy level, but when it goes to higher energy level, it is not stable. Again it jumps from higher to the lower energy level by losing energy, we can say that. Clear? So this already I have explained you. Now what is the interpretation we get it? That is, see, Now here we need to calculate the maximum number of lines which is produced when an electron jumps from nth level to the ground level. So what is the formula? N into n minus 1 by 2. Alright, for example, say I have given you here, if n is equal to 4, then theoretically if you calculate, mechanically if you calculate, then electron will come from 4th level to the 3rd level. It can also come from 4th to the 2nd. It can also come from 4th to the 1st. So how many got it? 4th to 3rd, 4th to 2nd, 4th to 1. So 3 you got it jump? 3 you got it, 3 lines. Got it? Now next is, it can also be from 3 to 2. From 4 to 3 when it is coming, then it will come from 3 to 2. Then it will come from 3 to 1. So how many you got it? Initially you got 4 to 3, 4 to 2, 4 to 1, 3, and 3 to 2, 3 to 1. Got it? Third level to second level and third level to first level. Got it? So how many you got it? 5. And again when it comes to the second level, it can come from second level to the first level to the ground level. So it can be 2 to 1. So ultimately how many lines you got it? Again I repeat, when an electron is present in the 4th level. Got it? So how many maximum number of lines will be produced when an electron jumps from the nth level to the ground level, to the ground state, when it comes from the nth state to the ground state? That is what I am giving an example to you. Suppose if an electron is in the 4th state, so it can come from 4th to 3rd, it can come from 4th to 2nd, it can come from 4th to 1st, it can come from 3rd to 2nd, again 3rd to 1st, again 2nd to 1st. So how many you got it? 6. Altogether you got it, isn't it? So maximum number of lines produced is 6 in this way. So you can put that in the formula also, you can calculate 6. Like what I said, n into n minus 1 by 2, 4 into 4 minus 1, 4 into 4 minus 1, 4 minus 1 is what? 3. So 4 into 3 by 2. So 4 into 3 is 12, 12 by 2, so how much? 6. You got it in this way also. Did you get it? So when an electron jumps from n2 to n1, then the number of lines in the spectrum will be n2 minus n1 whole into n2 minus n1 plus 1 whole divided by 2, as I have given you in the screen. You can see is that. Got it? When an electron jumps from n2 to n1. Got it? So in this way it will be n2 minus n1 within bracket, then n2 minus n1 plus 1 whole divided by 2. Means n2 is given, n1 is given. Means suppose n2 is 4 and n1 is 3. Got it? So 4 minus 3 then 4 minus 3 plus 1 whole divided by 2 will give you the maximum number of lines produced. So you can calculate theoretically, mechanically, or also you can calculate by the help of formula in this way. So these are the interpretation which was given by the Bohr's, what you can say, atomic model regarding the spectral lines of the hydrogen atom, so to say. Now the rest of the things I have given you in my notes, you can see that, that is, I feel that if by reading that particular notes you can understand it. It's not difficult, that is, you can understand those things. So I have given you in my notes, and let me see some more thing, I'll send it to you. Thank you very much.